In drilling operations, predicting rate of penetration is critical for performance optimization and cost reduction. Follow along to learn step by step how to predict rate of penetration based on deep learning and artificial neural network. So the first thing that we're going to do is start reading the data. We are going to take a look at the data by calling the variable that holds the data, which is the data frame. And then we're going to start to plot the rate of penetration as a function of depth. So for that, we're going to use a simple plotting technique. So we're going to take advantage of the columns, and we're going to treat it as a scatter variable or scatter plot. So this is what it looks like. Now it's time to start building our plot and building the line plot to see. Once we have decided on the columns that we are going to use for training the model, we are going to start to do a little bit of data cleaning and then deciding on the X and Y variables. The X is going to be a bunch of columns that we're going to use for training, but you can use any column you want. And for the model, we're going to create a Keras sequential model that's going to scan our data from top to down or left to right based on the order of the layers. So the first layer is going to be an input layer with 8 neurons, and the definition or the input dimension is going to be the same length as the number of columns we have. And for the second layer, it's going to be a hidden layer that's going to be used for calculation and the hidden weighting process. So the last data layer is going to be for the output with a single output function because we only have a regression task at hand. Next thing, we're going to compile the model, and we're going to set some losses and metrics for our monitoring, and we're going to fit the model, and basically we're going to tell it to iterate 20 times, and we're going to start running the model. Now this is a run of the model that's going to be based on the approach of rough model building, and then we're going to iterate and tune the model to make the model a little bit more better than before. So let me show you now what the results look like. So the results is not the best in the world, but we are going to improve this model as we are going along. So this is what it looks like, the actual data against the predicted data. So the next step we're going to do is we're going to adjust the model, and first we're going to adjust the data to make sure that the data are already scaled, and scaling the data is quite important for this process. So we're going to insert the X to be scaled in the fit transform, and once we scale it, we are going to run the model one more time, and now you can see the results are much more closer than to the reality. And follow us for more videos.